In this video, you're going to learn how to write the equation for a sine or cosine function given the graph. And we're going to go through 4 examples together. I'm going to show you how to work through these, and you can pause and practice some of these on your own if you want. But let's jump into the first example. So we're given this graph here, and the question is do we want to write it as a sine or a cosine graph? Well, we're going to do both, and I'm going to show you how to switch between the two different forms. Now, the first thing you want to look at are some formulas here. You can write these down, and I'll kind of show you where these come from as we go through. But we're going to be working with equations in this form here. Y equals a sine b x minus h plus k, or y equals a cosine b x minus h plus k. The a is the amplitude. That's how high the waves are. But keep in mind, these waves, you're measuring them from the midline. So for example, from this midline here, or from this midline here, that's the amplitude. It's almost like you're standing on the beach and you're looking at how high the waves are in relation to the shore. So one way to do this is you can take the maximum or the high point minus the minimum, okay, the low point, take the absolute value and then divide by 2, and that's going to give you this amplitude. So the amplitude's always positive. We can write this as a negative value if you want to reflect that over the x-axis, but just for finding just the amplitude, this is a good formula to know. So in this problem here, what we can do is we can see that the maximum here is at 5. The minimum or the lowest it goes here is 1. So using this formula, we've got 5 minus 1 divided by 2. So that's 4. The absolute value of 4 is still 4. Divided by 2 is 2. So that's how high these waves are. Another thing I like to do sometimes, and you might want to do this as well, is you can draw in like a midline, and then you can count, what's that amplitude from this midline? Oh, I'm going up 2 or I'm going down 2. So let's just make a note here, a equals 2. Now the next thing is the k value, which represents the vertical shift up or down. And the way that you can find this is by taking the maximum plus the minimum divided by 2. So here we could say 5 plus 1 divided by 2. So that's 6 divided by 2, which is 3. Okay, so that's our k value, which means that this graph has been shifted up 3 units. And you can see normally this midline is right here on the x-axis, okay, but now it's been shifted up 3. Now, as far as the period is how long it takes for it to complete one cycle. So you're probably familiar with the basic sine graph and the basic cosine graph. One way to look at it is, how long does it take to get from the maximum to the maximum, or the minimum to the minimum, or just you could look at how long does it take for it to repeat. So in this case, I can see I could measure from here to here, and it looks like I'm counting by pi. So this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So this is 5 pi here, 1 pi here. So that looks like that's a distance of 4 pi. So that would be our period. Let's just write that down. So 4 pi. But what we're really after is this b value. Okay, so we're going to solve for b. So 4 pi equals 2 pi divided by b. What you can do is you can multiply both sides by b to get rid of the fraction here. And then if I divide by 4 pi to solve for b, I get b equals 2 over 4. Since the pi's cancel, that comes out to 1/2. So our b value is 1/2. And now what we're going to do is we're going to look at the phase shift, or the horizontal shift, okay, shifting left or right. And in this case, I think what I'm going to do is I'm going to make this a cosine graph to start off with. Notice the cosine graph starts at the maximum, or the high point. That would be this point right here. So it goes down and back up. That's a complete cycle. But look what's happened here. Normally cosine starts right here, right on the y-axis, but here it's been shifted to the right pi. So in this case, this h value is going to be equal to pi. So let's go ahead and put all that together. We've got y equals the amplitude, which we said was 2. We're going to do this as a cosine graph first. Our b value we said was 1/2. And we're shifting to the right pi, so x minus pi. And the whole graph has been shifted up 3 units. That's our k value. Okay, so that is one way to write the equation. Now, sometimes your teacher will say write it both using a sine and a cosine graph, or maybe they'll specify one or the other. But what's interesting, when you write it as a sine graph, the amplitude is still going to be the same. The b value is going to be the same. The k value is going to be the same. The only thing that's different is the phase shift, left or right. And one thing that's interesting here is that the only difference between the sine and the cosine graph is that they're out of phase by a quarter of a period, okay? So normally the period here for sine and cosine is 2 pi. You can see here, if I was to kind of carry this cosine graph a little bit further like so, if I was to shift this just 1/4 of 2 pi, which is pi over 2, now I would have the sine graph. So you can see it's just, again, out of phase by a quarter of the period. In this case, the period we said was 4 pi, so a quarter of 4 pi is 1 pi, right? And so really what you can see is that it's just being shifted by a pi to get that sine graph. Now notice the sine graph, it starts right here at the origin, at the midline, okay, and it goes like this, right? And you can see that right here, this is, you know, like a start of one cycle of our sine graph. So you can see right here, we really aren't shifting left or right, we're just shifting up 3. So in this case, we don't need an h value here, and that's our sine graph. Now you might be saying, Mario, isn't there another possibility? Well, there's actually like an infinite number of possibilities here because this graph keeps repeating, you know, in both directions. It's just really a matter of where do you want the starting point to be? Do you want to, like I could say my cosine graph starts right here, and I could say, oh, this whole thing shifted to the right, whatever this is, 1, 2, 3, 4, 5 pi, so I could make this x minus 5 pi. But the amplitude, the b value, the vertical shift, all that's still going to be the same. So same thing with the sine graph. You know, I could say like, oh, maybe I want to start right here, okay, and make this like a negative sine graph, like it's been reflected over the x-axis. A lot of different possibilities, but I try to basically pick a point that's not been shifted too much left or right, so kind of close to the y-axis. I don't want to go way over here and say it's been shifted, you know, whatever, how many pi to the right or how many pi to the left. So I try to keep it kind of close to this origin here. Let's take a look at another example. Okay, see if you can do example number 2 here. And I've tried to highlight some key points here for you when you're writing this equation. And, you know, don't be afraid to make a mistake. You know, you definitely learn from your mistakes. You know, I had a friend in high school, his father owned a machine shop, and he used to tell his son that one yes is made up of many no's, basically meaning that a lot of failures are going to precede, you know, a success. So I definitely encourage you to try to fail faster, and then you'll catch on to these a little bit quicker. But in this example here, number 2, what do you think? Let's go through it. So we want to take a look at the amplitude. Okay, and remember the amplitude is how high the waves are. We can take the maximum, meaning the high point, minus the minimum, the absolute value, divided by 2. So we've got 2 minus negative 4 divided by 2. So that comes out to, well, when you subtract, it's like adding the opposite. That's 6. The absolute value of 6 is 6. Divided by 2 is equal to 3. Okay, so that's going to be our amplitude, 3. Now how about our vertical shift, our k value? Well, we're going to take the max plus the min divided by 2. So we've got 2 plus negative 4 divided by 2. So that's negative 2 divided by 2, which is negative 1. Okay, that's our k value, which means that this graph has been shifted down 1. So again, what you can do is you can draw on a dashed or dotted line. This is kind of like what I think of as like a midline. Normally that midline is right on the x-axis, but here you can see it's been shifted down 1. Now, as far as the period, we want to figure out how long it takes to complete one cycle. Now, again, an easy way to do this is to go from a peak to peak, or valley to valley, or high point to high point, low point to low point. Or if you can identify maybe where it's starting and then completing one cycle, like I could maybe go from here to here. That's one way to do it. But I think because I'm given these points here, and this is kind of a rough sketch that I've drawn, I'm going to say from negative 3 to 5, that's a distance of 8 units for it to complete one cycle from peak to peak. So our period is 8. So what I'm going to do is I'm going to solve for our b value. So we've got 8 equals 2 pi divided by b. I'll multiply both sides by b to get rid of that fraction, and then I'll divide both sides by 8 to get b by itself. So that comes out to pi over 4 if I reduce. Okay, so that's our b value. So now let's take a look at writing this as a cosine graph first. I think that's oftentimes a little bit easier. And again, I'm going to think about, let's see, what does cosine look like? It normally starts right here at the maximum, this high point, and it kind of goes down like that. So I'm going to think of this as my starting point right here, but you can see it's been shifted to the left 3. So let's go ahead and write our cosine equation. We have amplitude, which is 3. Cosine graph, our b value is pi over 4. X plus 3. Remember, the number that's grouped with the x, that's going to have the opposite effect on the graph. So the plus 3 is actually shifting it left 3. If it was minus 3, it'd be right 3. And we said the k value was negative 1. It shifted down 1 unit. Okay, so this is one possibility. If you didn't get this particular equation, it may be that you had picked this as a starting point, okay? Or maybe you wrote it as a sine graph, or maybe you had a reflection over the x-axis first. So let's look at maybe a possibility for the sine graph. Remember, we said it has the same amplitude, has the same b value, it has the same k value. Now we just want to figure out about the phase shift or the horizontal shift. And so one way to do this is to think about the fact that these are out of phase by 1/4 of a period, right? And we know that the period we said was pi over 4. No, that's our b value. Sorry, our period was 8, right? Here it is, period is 8. So 1/4 of 8 is 2, right? So what we can do is we can say that, okay, it's out of phase by 2 units, right? So see here, this is at negative 3, 2 units. Oh, there we go. That's negative 5 right here. That's the start of one sine graph, right? So that's one possibility. I could say that this is being shifted all the way over here, left 5. So this would be x plus 5, okay? That's one idea. Another idea is, notice from here to here, this is half a period. That's pi. In this example, that's going to be half of 8, which is 4. So 1, 2, 3, 4. I could start right here, but you can see this is like a sine graph that's been reflected, over the x-axis. So another option would be y equals negative 3 sine pi over 4. And in this case, it's just being shifted to the left one. So I could say x plus 1. So you can see a lot of different options, but if you can identify the amplitude, the b value, the k value, which is a vertical shift, then you just have to figure out, where do I want this graph to start? What's my phase shift? Let's take a look at another example. See if you can get this next one. Okay, what do you think for example number 3 now? Well, let's follow that same process again. Let's go ahead and find the amplitude first. So we're going to take the max minus the min, take the absolute value and divide by 2. So here it looks like the max, the high point here is at 3, the low is at 1. So we're going to say a equals 3 minus 1, absolute value divided by 2. So that's going to be 2, divided by 2 is 1. Okay, so that's interesting. Now the k value, the vertical shift up or down, we're going to use this formula, the max plus the min divided by 2. So that's going to be 3 plus 1 divided by 2. So that's 4 divided by 2, which is 2. So that's interesting. So that k value 2 means that this graph has been shifted up 2 units. That's going to be like our new midline here. Okay, like that. So normally that midline we said is at the x-axis, but now it's being shifted up 2. And the period, let's see, the period is how long it takes for it to repeat. Now, you might be working on a worksheet right now and thinking, well, Mario, I'm not always given like a nice convenient maximum and maximum, good for you, right? You got it easy, right, Mario? But yours might give you maybe a minimum and a maximum. And so here's where you have to kind of think and say, well, wait a second. From the minimum to the maximum, that represents a half of a period. So for example, if I know that this is 2 pi over 12, which is pi over 6, and this is pi over 3, which is 2 pi over 6. So how do I go from pi over 6 to 2 pi over 6? Well, that's pi over 6. That's half a period. So if I then double that, I can get 1 full period, right? So that's one way to do that. That's how I can figure out, like in this case, I have from 0 to pi over 3. That's a period of pi over 3. But again, if you know half the period, just go ahead and double it, right? So minimum to maximum is half a period. So let's just write that down. So period is pi over 3, but we're really after the b value. Remember, the b value is related to the horizontal stretch or shrink. And we're going to solve for b. So let's see. So here I can see that if I cross multiply, that's one way to do it. So that's pi times b is equal to 6 pi. And if I divide both sides by pi, I can see that b is equal to 6. Okay, so that's interesting. So now let's take a look at the phase shift. Now, if I'm working with cosine, which I tend to like to do first, I know that cosine starts at the maximum, right? So in this case, it looks like the cosine graph has not been shifted left or right. So our h here is going to be 0 for the cosine. So let's go ahead and write that one. So we've got y equals amplitude, which is 1. Of course, we don't really have to write 1 because 1 times anything is itself. But I'll go ahead and put it in there, cosine. The b value we said was 6. It's not shifting left or right, but it is shifting up 2. And that's it. If you want, you could put this in parentheses. You don't have to. That's our cosine graph. Now, if we want to write it as a sine graph, y equals same amplitude, sine, same b value, 6, same vertical shift, up 2. But where does the sine graph start? It starts right here, right? Or you could think of it as 1/4 of a period, okay, shift. So in this case, we said our period was a pi over 3. 1/4 of pi over 3 is pi over 12. So I can see that this is 1/4 of a period, which is pi over 12 to the left. So I could write this as x plus pi over 12, because remember, whatever is grouped with this x here has the opposite effect. The plus pi over 12 is going left pi over 12. And again, there's more than one way to write this equation. If you wanted to start over here and say, okay, I can recognize that this is a sine graph like that, I could say that it's being shifted to the right 1, 2, 3 pi over 12, which is pi over 4. I would just have to make this x minus pi over 4 since it's going to the right. So a lot of different possibilities that you can explore here, but if you can zero in on the amplitude and the b value and the k value, then it's just a matter of that phase shift. So let's take a look at one last example. See if you can get this last one. Okay, see if you can get this last example, number 4. This one I tried to make a little bit more challenging. I didn't label the axes here, but I did label some key points, this minimum and this maximum point here. See if you can get the equation for this as a sine and a cosine graph. So really test yourself. And while you're doing that, if you like the way that I explain things and you want to go deeper with me into learning math, check out my Algebra 1 as well as my Algebra 2/college algebra course in the description below. I've got a link to both those courses, and they're definitely worth checking out. Also, if you just want to support what I'm doing here on my Mario's Math Tutoring YouTube channel, you can join as a member for a few dollars a month. You can be a channel member, and I'll see when you comment, I can recognize that you're a channel member, and that's kind of a nice feature there. And it just kind of helps me to keep going with this channel. So let's dive into this last example here. What I would do is find the amplitude, right? So let's go ahead and do that. Max minus min divided by 2, but you want to take the absolute value. So 3 minus -5 divided by 2. So that's going to give us 8 divided by 2, which is 4. Okay, now how about the vertical shift, the k value? We're going to take the max minus the min, the max plus the min divided by 2. So 3 plus -5 divided by 2. So that's -2 divided by 2, which is -1. So that's our k value. This is our a value. And let's look at the period now. Now this one, see, we're going from the minimum to the maximum. Remember how we said that's a half a period? So 3 pi over 16 minus 1 pi over 16, that's 2 pi over 16, which reduces to pi over 8. But since that's half of a period, we have to double that. So that's actually 2 pi over 8, which is pi over 4. Okay, so that's one period, pi over 4. But we're interested in solving for the b value. So let's go ahead and do that. We've got pi over 4 is equal to 2 pi over b. If we cross multiply, we get pi times b equals 8 pi. So just multiplying on the diagonal. And if we divide by a pi to get b by itself, we get b is equal to 8. Okay, and now as far as the phase shift, let's start with the cosine graph. The cosine starts at the maximum, right? So we could say that this graph starts here. It's just been shifted to the right 3 pi over 16. That's one way to do it. Let's see, what's another way to do it? We could also use this point right here, which now notice that the period we said was pi over 4, which is 4 pi over 16. So if I was to go 1, 2, 3, 4, that puts us here at negative pi over 16. I could use this point. I would be tempted to use this point a little bit more just because it's, less of a shift, but you can use either one of these. So let's go ahead and do that. We've got y is equal to the amplitude, which we said was 4, and then we've got cosine. Our b value we said was 8. We said we're going to be shifting to the left pi over 16, so that's plus pi over 16. Or we could do x minus 3 pi over 16. And then our k value was -1, so it's been shifted down 1, which means that our midline is right here. Okay, now if we wanted to write it as a sine graph, what we could do is we could say y equals, now this is interesting, so the sine graph, we could use this point right here and do it as a negative sine graph, right? Okay, the only challenge sometimes, you might be given a worksheet or a problem where you don't have all these points, labeled basically. You might just have to figure out, okay, what's a quarter of a period? We said our period was pi over 4, so a quarter of that is going to be pi over 16. So it's a pi over 16 phase shift. So basically, like if this is my cosine, if I'm starting up right here, okay, as a starting point, a quarter of a period would be a pi over 16, which you can see here we're counting by 1, 2, 3. See, we're counting by pi over 16. That's our scale. So basically, that would be right here. So we could think of this as the start of our sine graph, and that's 2 pi over 16, which is pi over 8 if we reduce. So we could say x minus pi over 8, since it's shifting right pi over 8, this has the opposite effect, right? Still the same vertical shift down 1, still the same b value 8. So that's another possibility. We could also see here, this is like, you could do this as a negative sine graph, see? So you could actually say, oh, this has been reflected. See, here's your sine graph reflected, and make this a -4, but then there wouldn't be any phase shift. There would just be the shifting down 1, the amplitude would be 4, but then it'd be a negative because it's been reflected. So a lot of different options. So I hope this video helped to clarify writing equations given the graph for sine and cosine. If you want more practice, I'll put a link to another video that I did on the same topic right there. Go over there, test yourself, practice some more problems, and I'll see you in my other videos. I'll talk to you soon.